Tomorrow we have our test 4 covering this idea of integration and look at all the details we covered here today. We started out looking at the antiderivative or indefinite integral, and lots of different rules for that. And even as we calculate the definite integral, first thing we try to do is find the antiderivative or indefinite integral from that. So very important to be able to do this. Antiderivatives, indefinite integrals, you have your power rule. And sometimes we have to manipulate the expression algebraically, such as 1 over x cubed, we have to change to what?
1x to the
Okay. Yeah, x to the negative 3. Yep. And then it's in the form add 1 and then divide by n plus 1. And if it's an antiderivative, if it's an indefinite integral, we need the plus c, because we're saying what function has x to the negative 3 as a derivative, and that can be this function plus any constant. Yep.
So we can leave it like that.
Yeah, you could leave it like this, but it's probably easier to, the 2 would stay in the denominator and then x squared as well. So I'm fairly lenient with how you leave the form, but now if we're using this later on when we calculate definite integrals, you'll want to change it to this form so you can actually see what the value would be. It's hard to calculate 3 to the negative 2. So, but yeah, as far as this correct answer, I would accept this, but it would be better if you can go ahead and convert it to that. And again, don't forget that plus c on the antiderivatives. Now, whether it's this or maybe even that, the hardest part on some of this stuff is working with the algebra, recognizing what this needs to be changed into. This one would be what? Okay, right, x to the 3/4, and then from there do your power rule and stuff. So power rule is fairly simple, but sometimes the hardest part's getting the x raised to a power rather than a root or a fraction. Okay. And not only that, then we got into looking at how to use substitution to change the form. So integrate by substitution, and we did a bunch of those. We did 3 different worksheets on just the substitution. So plus then later on we saw that a lot as well. So make sure you're able to do your integration and especially the substitution. And those of you going on to Calc 2, you'll see substitution an awful lot. So you need to know how to do the integration by substitution. Sometimes it's a very simple substitution, pretty straightforward. Other times it gets quite involved, and a lot of times the hard part with substitution is figuring out what to let u equal. And that can be kind of tricky, but we went through lots of different antiderivatives indefinite integrals looking at that. So, okay. And with the substitution, again, a couple different approaches and working through it. By now, you've probably decided what works best for you, so do it that way. Basically, the first several problems on the test will be find the indefinite integral, or antiderivative, or whatever you want to call it, but going through this process, and that's the integral symbol without any numbers at bottom and top. Those numbers we get into calculate the definite integral, but this is just your function that has the derivative given to us inside the integral. So several of those, they'll be mixed together, so it might just be simply power rule, might be some substitution, some combinations of substitution, might be some trig functions. All those trig functions, you gotta kind of think backwards on those, and which one's the negative, and I always have to think, okay, derivative, we go this way. Derivative of sine is cosine. So the integral of cosine is sine. And that's just the way my mind works, and maybe that'll help you guys out as well. But also with the e to the power and natural log, 1 over u du turns out to be natural log. So lots of different rules for the antiderivatives. Hopefully by now you have those down pretty good. Okay. Now the next set of problems are going to deal with leading up to the definition of the definite integral. Some of the things we looked at were summation. I may have a problem or two dealing with, here's the summation of something, write out term by term what that means, or vice versa, here's a bunch of terms, simplify that down to a summation. Like we did on the first few problems of the summation and approximating area worksheet. And then, of course, the approximating area, very important as we led up to our definition of the definite integral. In the approximation, we focused on just using the rectangles. Use 4 rectangles. Now in the homework I had you do both 4 and 8, but on the test I'll limit that to just 4 so you can get it done tomorrow. I don't want to be here till 5 tomorrow night, but 4 rectangles, and I will specify either left endpoints or right endpoints. Could be one of each, could be just one. So make sure you understand what that means, how to work through that. Finding the area under a curve from, say, 1 to 3, and using 4 rectangles, using left endpoints, okay. Or find the area using right endpoints. So, okay, questions on any of that part so far? There will be a problem of using the definition of the definite integral. I'm not going to put a bunch on there, but there will be one using the definition. Now, I will limit it at least to a few of the nicer things, but something like this, use the definition of the definite integral to evaluate this definite integral. So what you have to do there is go through the limit. You can, even though the definition involves the norm approaching 0, you can go ahead and go directly to n approaching infinity, because we are assuming delta x is going to be the same for every subinterval. So summation of f of c sub I times delta x, well, delta x sub I, but delta x, and I going from 1 to n. So figure all that stuff out. This one, delta x would be what? Okay, right. B minus a over n. So 2 over n. Okay. Then that kind of takes care of this part. The most amount of work is calculating this, and actually calculating the sampling point, which, like I said before, we can always choose the right endpoint, which will make notation a lot easier. That'll be your choice, but let me give you a good suggestion. Choose the right endpoint. Choose x sub I for our sampling point. So x sub 0 is 1. Then x sub 1 would be what? We've got our interval here from 1 to 3. We're partitioning this into n subintervals. X sub 1 is going to be represented by what? Okay, but 1, we start at 1 plus delta x. To get, well, that's a nice, to get from 1 to the next x value, we go delta x, the width of each subinterval. Okay. Then to get to the next one, we'll have what?
Plus 2,
Correct. And in general, it's going to be whatever we start with plus I times the delta x. So x sub I being our sampling point, and we do need to put in the exact value we found for delta x. So x sub I will be 1 plus I times 2 over n. Okay. Now again, that probably is the most difficult, the most amount of work to do. We still need to plug that into our function though. And our function here, f of c sub I, we would have 5 times the x value. Well, x value is going to be 1 plus I times our delta x. So 5x minus 2. That will be our f of c sub I. And most cases we'll be able to simplify it at least a little bit. Then we'll plug in all of the particulars into our limit. And then a few more things. f of c sub I was that 5 times our x sub I minus 2, and then times our delta x. And from here, 5 plus 5i, 2 over n, and then minus 2. Well, our constant, our f of c sub I, would simplify to 3 plus, well, 5 times the 2 over n, leave us with 10 over n times the I part. And then summation, still got the limit. And then at this point, evaluate the summation of both of these terms. Now, this is where we looked at 3 different formulas. I will expect you to know the summation of a constant and the summation of I. I'm not going to throw I squared at you. We'll make it somewhat easy since you got to remember these. So, summation of a constant, I goes from 1 to n, is going to be what? That constant times n. So that's what we'd have here. Applying the summation to 3, that term would just be 3n. Okay. And then this term, summation of I, what's that formula? N times n plus 1 all over 2. And that expression would be substituted in here. So we'd have the 3n plus this times the 10 over n, and then all of that still is times your 2 over n, clear on the outside. And then it becomes a huge algebra problem, and finally just a little bit of calculus at the end, taking the limit. So, questions there? Now, a problem like this, you should be able to find the correct answer even if you don't do this part right. You should be able to do it using the fundamental theorem, but on that particular problem, when I say use the definition of the definite integral or the limit process, I need to see all of this, but definitely you can check to make sure you did it right going through the easy fundamental theorem. So, but that's usually the one problem that is the hardest to work through. There's lots and lots of steps, lots of things to remember, but each step individually isn't all that difficult. It's just the combination of all of them get a little cumbersome. Then we looked at the big E. This is, well, just the name of it, the fundamental theorem of calculus. That's extremely important in the area of calculus. It's essentially relating the derivative and the definite integral together, and we find, well, he talks about a couple different parts of this fundamental theorem. Given a function, we could, well, given a function in the definite integral format, the one direction, essentially find the derivative of this function. Well, some functions we could actually go through and calculate the formula of it, getting rid of the definite integral part. then take the derivative of it. And just to kind of go through that, I picked one easy enough that we could do that. Antiderivative of t cubed, t to the fourth over 4, evaluated from 1 to x. We'd have x to the fourth over 4 minus 1 to the fourth over 4, and that is our capital F. Well, this is a lot more work than we need to do, because if we understand the fundamental theorem, when we take the derivative of this function, then what do we end up with? Well, we'd have 1/4 of derivative of x to the fourth, 4x cubed, and then the derivative of a constant 0. Well, guess what? That is just x cubed. Well, we had t cubed inside the definition of the function, inside the integral, but in terms of x, it's just the cube of that variable. So the derivative and the antiderivative, or the derivative and the definite integral, are inverse operations. If we do one and then we do the other, basically cancels out the operations, and we end up with this. Now, make sure f primed of x, make sure it's in terms of x. You might look at this and say, well, the derivative would be t cubed. Well, not quite. The derivative of this function would be the cube, but the cube of x, not the cube of t. Okay? So that's kind of the first part of the fundamental theorem. Then the second part, we use the fundamental theorem to evaluate definite integrals or to find areas and so forth. So we may have something like find the area under y equals x squared over the interval from 1 to 4. Graphically, from 1 to 4, and not quite to scale, but 4, this would be 16 clear up here, but anyway, the definite integral going from 1 to 4 of the function. Find your antiderivative, and then finally the fundamental theorem says we evaluate it for the top number, then minus, evaluate it for the bottom number, and we get 64 over 3 minus 1 over 3. 63 over 3 would be, what, 21? So that's the value of that definite integral, but that value also represents the area, oops, not here, from 1 to 4 under this curve. So we've talked about area using the definite integral. We've looked at evaluating definite integrals. And one more kind of special case of the area under a curve. I'll just draw something up here that let's say we have this 1, 2, 3, 4, 5, 6. And if we want to integrate this function from, say, 0 to 6, how would we do that? we'd have to break it up into parts that are above the x-axis and parts below the x-axis. So this part right here is above. Technically, we'd be breaking it up this way, 0 to 1, which that value would be what? Area of that triangle, which is 1/2 times base times height. Base of 1, height of 1, so area would be 1/2. Then from 1 to 3, that area would be what? Let's see, 1/2 times 2 times 2. That area would be 2. But for the evaluation of the definite integral, we'd have to say that value would be what? Okay, -2, because this area is under the x-axis. So far we've got 1/2, -2, then from 3 to 5, that area is what? One-half base times height. Base would be 2, height's 1. So again, because that's under the x-axis, the definite integral value would be negative. And then finally, the last little bit here from 5 to 6, and that area, well, that again will be 1/2. So the definite integral from 0 to 6 for this function, defined by the graph, will be, let's see, -2. We have +1, -1, -2. Okay? Questions there? We did lots of evaluating definite integrals, finding area, and the last thing we looked at, yesterday we talked about the approximating the definite integral using either the trapezoid rule or Simpson's rule. And there could be a problem of either or both of those. The biggest problem with this would be the formula. And for the trapezoid rule, it's going to be 1/2 and then b minus a over n, or if you want to think that's your delta x. In these, again, I will specify how many intervals or what n should be. N equal 4, n equal 6, n equal 8. I'll try to keep it somewhat doable again. But we're going to have 1/2 delta x and then times f of x sub 0 plus 2 f of x sub 1 plus 2 f of x sub 2 and so on. 2 of the f of x sub n minus 1, and then finally 1 of the f of x sub n. So depending on how many terms we have in there, okay, the first one and the last one we multiply by 1. All the others we multiply the function value by 2. And then Simpson's rule, little bit more to kind of think about there, but 1/3 instead of 1/2, but 1/3, and then the b minus a over n. And Simpson's rule goes 1 times the first one, and then alternates 4 times the second, 2 times the third term, or f of x sub 2, then 4, and so on. 4 would be the second to the last one, and then f of x sub n is going to be your last one. So very similar rules, something you will need to remember. You won't have that written down on the test, or you won't be allowed a note card, but very, very similar formulas. You should be able to remember that. So 1 or 2 problems of, here's a definite integral, approximate it using the trapezoid rule with n equals, I will tell you how many n's, or what n is, I guess. So whether it's trapezoid or Simpson, or maybe one of each. So there are 20 problems on the test, so each one will be worth 5 points. And that's pretty much it. Any questions about the test? Now I will allow you to start early if you want. I'll be here probably around 8:30 if you want to get that started that early, but definitely by 9:30. I have another class taking a test at 9:30. So I'll be here, and you can stay after class as well, stay as late as you can. That's going to be up to you if you miss your next class, if you have another class at 11:30. But we'll see you tomorrow then.